This is a simple expansion board that I built for the Arduino Nano. It has a single potentiometer, 2 switches, some optocouplers, 3 LEDs, and a number of connections for jumper cables such as this to various projects. Right now it's programmed to do only this. If I press this switch, the LED on digital pin 9, which I label LED 1, comes on. Press the red switch, digital pin 10, which I label as LED 2, comes on. And then there's a third LED that's connected to digital pin 11. And as what this does, it reads the potentiometer, and only between from 401 to 799, as far as the pot goes. Remember, a analog read is a 10-bit value 0 through 1023 on an Arduino. Only from 401 to 799, as you turn through the range, does LED 3 come on. Alright, the rest of this is going to be simply an overview of the programming, the routines that I wrote for the switches and the pot, and the electrical layout, which we will be using for a number of motor control demonstrations. Here's the schematic to the little gadget board. It's just an Arduino Nano, very straightforward, but I'll explain why I chose the pins that I did. The switches S1 and S2 are connected to digital pins 2 and digital pins 3. On an Arduino Nano, these also happen to be your interrupt pins, which I may use for some later tutorials. The output, which is connected to some LEDs and will later be taken off at these points here to operate motors and other devices. These are simply indicators. Digital pins 9, 10, and 11 all have pulse width modulation outputs, which we will be making use of. The pot is connected to ADC0, it's connected to 5, and ground. With an Arduino Nano, you can operate it off a 5-volt supply, which is what I'm doing from my laptop, through the USB port, or you have the option of connecting your own 9 or 12-volt power supply or a 9-volt battery through VN. And here's a close-up picture again of the board. Again, we have 2 switches. This one's on digital pin 2. And this one's on digital pin 3. Here's 9 volts DC if you want to put it in and disconnect your USB as a standalone operating device. These 3 LEDs, this is LED 1, LED 2, and LED 3. These optocouplers, particularly these 3, are connected in, and I could use them if I wanted to. I probably won't in most of this series. Here is my 10K pot. I also put in a bypass capacitor for the power supply. This jumper leads over here to A0 or analog input 0. I can choose other analog inputs if I wish. I have that flexibility. You'll see a row of pins here. They are connections to the various pins on the Arduino Nano. This row here is for 5 volts. That row there is ground. Here is a row here that's also ground. Here is a row of pins here where you can get at digital pins 2 through 12. Digital pin 13 can be accessed up there. And all right, let's look at the software that I'm using with this. I wrote some custom commands to make writing these little motor control programs a lot easier. Alright, let's look at the Arduino sketch that I'm going to use for this series of little tutorials. I've defined SW1 as digital pin 2, SW2 as digital pin 3, and of course digital pins 9 through 11 are going to be L1 through L3, and then I'm going to define the word pot as 0. Remember that I used analog 0. I also defined the word on as 1 and defined off as 0. We shall take a look at why I did this, because it makes, when you do this and you write your main sketch, it's much, much easier to understand and keep track of things. I also made a series of 6 subroutines, real short and real simple. Here's the first 2. S1, void, and it returns a byte value. All it does is read switch 1 on digital pin 2. Remember, SW1 was defined as digital pin 2, and it will return a 1 if the switch is pressed, or it will return a 0 if the switch is open. Remember, when the switch is open, when you remember the schematic, and I've turned on the internal pull-up resistors, it will read a high when the switch isn't pressed and a low when the switch is pressed. I don't want to go through this constant digital read, SW1, is it equal to 1 or 0 or whatever. This simple command, S1, and all you have to do for the command is type in S1, and when you call that command, it's going to return a 1 if the switch is pressed and a 0 if it isn't. Makes life a lot easier. Same thing down here, S2 returns a byte value if SW2, which is digital pin 3, is pressed. If you push the switch, it'll return a 1, else it returns a 0. A word before we move forward. A byte value is defined as an 8-bit unsigned byte. Instead, so a lot of people try to use integer for this. You're wasting a byte. An integer takes up 2 bytes. A byte takes up 1 byte, since the only value being returned is 0 or 1. Good programming practice, don't waste your bytes. You really need them sometime for a really long program. And if you can make short routines like this, in the end, it makes the routines run faster. All right, let's move on down, look at the next subroutine that I wrote. It's the command pot. All you have to do to get a value from 0 through 1023 from analog digital converter 0 or whatever you're using, you just type in the word pot. There it is. Or there you go. You didn't have to run through all the analog read and all the other stuff. We will be looking in how to use pot. Just use the pot command, saves you from writing all of this. It's a lot simpler. Now I have 3 more commands, void LED1, and I'm going to send it a byte value, which I call temp. It's nothing but a digital write to L1. In this case, that would have been digital pin 9, the value of temp, and temp would have been a 0 or 1. Same thing with LED2. All you have to do, instead of going digital write LED1, comma low or high or all that. You're constantly writing it. All you got to do is LED 1 on if you want to turn the LED on, because remember, I defined on and off as 1 and 0, or LED 1 off, instead of writing digital write L1 off or on or whatever. This is what you're going to see in loop. And we're going to look at loop momentarily and play around with it. And all three of these commands are identical and are used in the identical same manner. Let's take a real quick look at your setup. Unlike other versions of C or C++, Arduino comes with this setup routine that defines your digital I/O pins. Everybody should know this. I remember I defined L1, L2, and L3 as digital pins 9, 10, and 11. They're all going to be outputs. I had switched to SW1. Remember, that was digital pin 2. That has to be an input. And I'm going to write a high to SW1. It turns on the internal pull-up resistor. Same thing with SW2, which is digital pin 3. It's going to be an input, and I can write a high to that to turn its internal pull-up on. Remember that your Arduino compiler defines high as a digital 1. I could have put in, instead of the word high, could have put in 1 and did the same thing. Or could have put in on and do the same thing, because remember, what did I define the word on as? 1. 1 is defined as a high. All right, that's your setup. Let's move on to our famous loop. To reiterate again, I define the word on as 1 or high. I define the word off as 0 or low. I have a subroutine S1 that will return a 1 if the switch is pressed, 0 if not. Same thing with S2. I can also call pot, which will return me of a value from the analog to digital converter in the potentiometer of a 0 through 1023. Then I have the three little subroutines, LED 1, LED 2, and LED 3. You can pass them a 1 and a 0, and the appropriate LED will turn on or turn off. With that in mind, let's drop down to loop. We've already been through the setup. Here we are at loop. This is what you would normally see to test a switch. We defined an integer temp. Could have been byte, but I'll just leave it integer for right now. Temp, of course, we can do a digital read to SW1. Then we're going to use an if statement. If temp is equal to low, that means I press the switch, then digital write to L1, which is digital pin 9, a high. We turn the LED on digital pin 9 on, else we're going to turn it off. Same thing down here. We can do it digital read SW2. We'll compare temp again, and if it comes back a low, it'll turn the LED. It should have been L2, which is the second LED, on or off respectively. Every time you test a switch, you've got to go through all of this stuff. let's see how my little subroutines will save you a bunch of headaches. First of all, we don't need that line. Let's replace temp with S1. You've got to put both parentheses in there. But now I know if it's pressed, if the button is pressed, it will actually return high. So I can reverse this, and it will if I press the switch, the L1, the LED will turn on, or else if I'm not pressing the switch, it will be low. What do I mean by high or low? We basically know what it is, but wouldn't it be easier to use on? If I call S1 and I press the switch, I'm going to turn L1 on. Else I'm going to digital write L1 low. Well, we can replace low with off. But it gets a little bit easier. Let's note some facts here. Looking down here, true is any number not equal to 0. False is 0. So what is your basic structure of an if statement? If true, do this, and that should be like that, or else do this. So the idea is if this statement in here is true or high or anything but 0, my LED is going to turn on. I do not need this. I can leave it out completely. You might want to put a space between the outer if parentheses and the two parentheses on the subroutine. It's just going to call the subroutine directly. If it's pressed, it'll come up a 1 and be true and cut L1 on. If it's not, it's going to be false and it'll make sure that L1 is cut off. We hear so far so good. But why do you really want to continuously write digital write all the time? Why not use my little subroutine, LED1, on? Does the same thing. Why don't we come down here and use the same routine again, LED1, off. So I have reduced this 3 lines of what? Probably 50 characters down to this. If S1 is pressed, it'll come up with a 1. It will be true. It'll turn the LED on, else the LED will be off. Isn't that a little bit easier when you're writing it down if you keep in mind what you're doing here? So that gives you an idea what we're doing with the little subroutines. This is a template. You can download it from my website. And only thing you've got to do, all of this is already made out for you. You can cut and paste, and then what depends on what you want to do down here in loop. Some people will put their subroutines after loop. It will compile and work just fine. I prefer to put them up here below my definitions and above setup. If you're going to define some variables, you probably want to put your variable definitions like temp, like you're defining an integer or whatever. You might want to put that above the subroutines. Keep yourself, have a certain order for doing things, and you're less prone to make mistakes and follow a consistent pattern. In following videos, we're going to look more closely at what we can do with an if statement. So this is an introduction to my little gadget board and the little sketch template that you can cut and paste. So check out the videos that follow in this series, and thanks for listening.